The equation y equals mx plus c. Learning intention. To find the slope, gradient of a line and determine when two lines are perpendicular. Success criteria. I can rearrange a line equation into the form y equals mx plus c. I can identify the slope m from the equation. I can find the slope of a perpendicular line using m1 times m2, so slope 1 times slope 2 is equal to minus 1. I can explain why two lines are perpendicular based on their slopes. The equation of y equals mx plus c. If the equation of a line is in the form of y equals mx plus c, then the slope is m, and the line intersects the y-axis at the point 0, c. So this red line here is our line, y equals mx plus c. The m part, so whatever number would be stuck onto the letter. So this can be positive, negative, whole number, fraction, decimal. So whatever number is stuck onto the x is our slope, and the point at which the line crosses the y-axis is known as the y-intercept, and this will always have an x value of 0. Will always have an x value of 0, and the y value will be whatever the constant is at the end of our equation. So the point 0, c is called a y-intercept. If a line is in the form of 3x plus 2y minus 8 is equal to 0, for example, so you've got an x, a y, a constant equal to 0, change the equation, so rewrite it to the form y equals mx plus c. So basically get the y on its own. So solve for y, make y the subject of the formula. The slope is the value of m. You can read it off then. Once you have it in the form of y equals mx plus c, you can just read off whatever number is stuck onto the x. Y equals mx plus c is the equation of the line formula. It's on page 18 of your formula book on the coordinate geometry page. Example 1. Find the slope of the line 3x minus 2y minus 9 is equal to 0. So we're going to rewrite in the form of y equals mx plus c. So we write out our equation, and we want to get the y on its own. So we're going to carry the 3x over the equal sign and the minus 9 over the equal sign and change their signs. So we're going to solve for y, get y on its own, or make y the subject of the formula. So the 3x and the minus 9 come over the equal sign and change signs. So we still have minus 2y, that stays the same. Next we have equals, and then the 3x comes over to become minus 3x, and the minus 9 comes over to become plus 9. Next, we're going to divide every term by the number stuck onto the y. So minus 2 is stuck onto the y, so we divide by minus 2, divide by minus 2, divide by minus 2. Now, minus 2 divided by minus 2 is 1. Anything divided by itself is 1. So technically, you get 1y, which is just y. And then minus 3 divided by minus 2 is going to be positive 3 over 2, because a minus divided by minus is a plus. If you're unsure of your rules of integers, you can just put this into your calculator. Minus 3 divided by minus 2 will give you positive 3 over 2. And then 9 divided by minus 2 is going to be minus 9 over 2. You can just leave them as fractions. You don't need to rewrite as decimals. So plus divided by minus is a minus. So now we have the y on its own. So we have our line in the form of y equals mx plus c. So we can see that the number stuck in front of the x is the m. So that's our slope. So the slope of this line is 3 over 2. So if we draw out the line, so this is the line y is equal to 3 over 2x minus 9 over 2. Or you could also call it 3x minus 2y minus 9 is equal to 0. Both equations are correct. So this is our line. And we can see that it crosses the y-axis at minus 4.5. And minus 9 over 2 is minus 4.5. So that's the y-intercept. So that's the y-intercept there at the end. And the slope is 3 over 2. So we're going to just double check that the slope is right by drawing in a sensible triangle. So I'm going to draw a triangle here. And we can see that the rise is 3 and the run is 2. So the rise is 3 and the run is 2. So the slope is equal to the rise over run, which is 3 over 2. So yes, it is correct. Find the slope of the line 5x minus 2y plus 3 is equal to 0. So again, we rewrite in the form of y equals mx plus c. So we're going to get the y on its own, solve for y, make y the subject of the formula. So we write out our equation. We're going to carry the 5x and the plus 3 over the equal sign and change their signs. So we're going to get y on its own. So the minus 2y didn't move, so that stays as minus 2y. Next we have equals. Then the 5x comes over and becomes minus 5x. The 3 comes over and becomes minus 3. So next we're going to divide every term by the number stuck onto the y, which happens to be minus 2y. So it's a coincidence it's the same number as the last example. It could be any number. So we divide by minus 2, divide by minus 2, divide by minus 2. And then minus 2 divided by minus 2 is 1. Anything divided by itself is 1. So you get 1y, which we can just rewrite as y. And then minus 5 divided by minus 2 is positive 5 over 2. A minus divided by minus is a plus. And minus 3 divided by minus 2 is positive 3 over 2. So now we have the y on its own. Now we have the line in the form of y equals mx plus c. And so now we can just read off the slope. The slope is 5 over 2. So here's our line. Y equals 5 over 2x plus 3 over 2. So let's start off with the y-intercept. So we can see that this line is crossing the y-axis at 1.5. And 3 over 2 is 1.5. So that is the y-intercept. And the slope is 5 over 2. So we're going to draw in our sensible triangle. And we can see that the rise is 5 and the run is 2. So the rise is 5 and the run is 2. And the line is going uphill. It's a positive slope. We read a graph like we read a book from left to right. And this line is going uphill. And it has a rise of 5 and a run of 2. So the slope is equal to rise over run, 5 over 2. So it is correct. Example 2. L is the line 2x minus 3y plus 6 is equal to 0, and M is the line 3x plus 2y minus 4 is equal to 0. Show that L is perpendicular to M. So it's important to note here that perpendicular slopes multiply to give minus 1. That's something that you need to learn off by heart. Perpendicular slopes multiply to give minus 1. So we're going to get both lines in the form of y equals mx plus c and then compare their slopes. So starting off with the line L, 2x minus 3y plus 6 is equal to 0. So just like in the last two examples, we're going to carry the x and the constant over the equal sign and change the signs. So the 2x comes over and becomes minus 2x, and the 6 comes over and becomes minus 6. So we still have the minus 3y, that didn't move, so that stays the same. Then we have equals, the 2x come over to become minus 2x, and the 6 came over to become minus 6. So we want to get the y on its own, so we're going to divide by the number stuck in front of the y, which is minus 3. So we divide each term by minus 3. And minus 3 divided by minus 3 is 1. Anything divided by itself is 1, so you get 1y, which is just y. And then minus 2 divided by minus 3 is positive 2 over 3. A minus divided by minus is a plus. And minus 6 divided by minus 3 is positive 2. A minus divided by minus is a plus. So now our line is in the form of y equals mx plus c. And we can just read off the slope. The slope is the number stuck on to the x. And the number stuck onto the x is 2 over 3. So the slope is 2 over 3. So then we do the same with the line m. So we have 3x plus 2y minus 4 is equal to 0. So we're going to carry the 3x over the equal sign and the minus 4 over the equal sign, and they will change signs. So the 3x comes over and becomes minus 3x, and the minus 4 comes over and becomes positive 4. We bring down the 2y, that doesn't change because it hasn't moved. Then we have equals, the 3x comes over, becomes minus 3x, the minus 4 comes over, becomes plus 4. So now we're going to divide each term by the number stuck in front of the y, and the number stuck in front of the y is 2. Now just be careful, it's positive 2 this time. So dividing each term by 2. So 2 divided by 2 is 1. Anything divided by itself is 1. So you get 1y, which is just y. And then minus 3 divided by 2 is minus 3 over 2. A minus divided by a plus is a minus. And 4 divided by 2 is 2. So now we have our line in the form of y equals mx plus c. So we can just read off the slope. It's the number stuck in front of the x. And it's minus 3 over 2. So the slope is minus 3 over 2. Now, you might notice that the slopes are very similar, but there are some differences. So the first slope the slope of line L is positive 2 over 3, and the slope of line M is minus 3 over 2. So one's a plus and one's a minus. You might also notice that the fraction 2 over 3 has been flipped upside down to become 3 over 2. So that's exactly what we want to see. So when we multiply these fractions, we should get minus 1. So perpendicular slopes multiplied to give minus 1. So 2 over 3 multiplied by minus 3 over 2. Well, a plus by a minus is a minus. And then top by top, bottom by bottom, 2 times 3 is 6, and 3 times 2 is 6. And minus 6 over 6 is minus 1. Anything divided by itself is 1. So we do get minus 1. Therefore, the lines L and M are perpendicular. So we know that the lines are perpendicular because their slopes multiply to give minus 1. So if I draw out the lines, we can see we have this line here that with an uphill slope is the line y equals 2 over 3x plus 2. And the line that is perpendicular to it, it has a downhill slope, and it is y equals minus 3 over 2x plus 2. We can see both of them have a y-intercept of plus 2, so the constant at the end of both of them is plus 2, and that makes sense because we can see they both cross the y-axis at 2. And then this one at the top here, so the one with the uphill slope has a slope of 2 over 3, so let's check if that makes sense when I draw in a sensible triangle. So we get a rise of 2 and a run of 3, and it's positive. So yep, that works. So a rise of 2 and a run of 3. A rise of 2 and a run of 3, so positive 2 over 3. And it's uphill, so it's positive. And then for the other line, the perpendicular line, we can see the rise is 3 and the run is 2. And this time it's going downhill, so it should be minus, and it is. So we have a rise of 3 and a run of 2, so minus 3 over 2. And we can see that we have 90-degree angles, so these lines are definitely perpendicular.